In these couple examples, we are going to try and we're going to draw slope graphs from original graphs. All right, so we're going to sketch these slopes from these original functions. All right, so here's kind of what I have. This one is kind of piecewise-ish kind of a thing. And we have these nice straight lines, which are perfect because we have slopes that we can count, right? We can figure out the rise and runs to this. So what I need to do over here is we transition at 2. We transition our slope at 0. And that's it. So we have a slope here, we have a slope here, and we have a slope here. So if I try to build mine, I have -2, and I have 0, and then I have these slopes that are going to remain constant. So I have this constant slope right here of -1. So from -2 on, I have a slope of -1. Right, so we'd have this negative slope. I guess we can cut it off at 5. -2, 3, 4, 5. So from -5 to -2, we have this constant slope of -1, right? -1 slope. So it's a -1 slope until we get to -2. At -2, our slope transitions to a +1. So we'll jump up and we have a positive slope from -2 to 0. Right? And then here we have a down 1/2. We have a slope of -1/2. So from 0 to 5, right, here's 5. So from 0 to 5, we are sitting at a slope of 1/2. Right, and then I'm going to close this one in. So let me talk a little bit of details of why I have these open circles and closed circles. At -2, I don't know which slope I have, right? I don't know if it's a -1 slope or a +1 slope. I don't have any information about it. So I'm going to not include those points because I don't know exactly what I have going on. And there's some issue with the fact that it changes so abruptly. We'll talk about that in a different session. But basically from -5 to -2, you got this constant slope because at -5, it's going down. So I can include it here. And then it ends, it doesn't abruptly change to something else at 5. So I can include it out here. All right, so that is our slope equation. Okay, so we have a negative slope from 0 to -2. And then we have a positive slope that doesn't change. And then we have a negative slope that doesn't change. It remains constant. All right, so let's say we want to do this one. Here's where I think it gets a little bit, we want to pick a couple pieces out of this one. Things that are nice are, we want slopes of 0. All right, 0 slopes are helpful. 0 slopes. All right, because when we graph this other one, we're talking about slopes. And so this point at -3, -1, and 1, those are slopes of 0. And if this graph is a graph about slopes, then at -3, we have a slope of 0. At -1, we have a slope of 0. And at +1, we have a slope of 0. Then we're talking about, we have positive slopes here that transition to negative slopes. So remember, all these y values refer to slopes. So we have positive slopes. Okay, and the higher the y value, the steeper it is. So as we're going here, we have all this steepness that starts to level off and get smaller and smaller and smaller until we get a slope of 0. So we have these y values that are bigger y values, but as we're getting closer here, we're talking about slopes that are getting closer and closer to 0. And then we have to transition to negative slopes. These are negative slopes. And what's happening is our negative slopes are getting steeper and steeper and steeper. So then it drops down until we get to some point where it starts to kind of level back off again. Our negative slopes get smaller, closer to 1 or closer to 0. That's them closer to 0. And then same thing. Now we have positive slopes that are going to get a little bit steeper until we get to some point. Then all of a sudden these slopes are still positive, but it's getting smaller. So still positive, but getting smaller. And then what happens with the rest of the slopes after that? They are nothing but negative slopes. Right? So we have positive slopes. We hit a slope of 0, negative slopes till we hit a slope of 0. Sorry, positive slopes till we hit a slope of 0, negative slopes till we hit a slope of 0, and then positive slopes, slope of 0, and then negative slopes. And it gets steeper and steeper and steeper as we go from there. All right, and then one last is same thing. We're going to be graphing the slopes of these 3 sections. All right, and so these 3 sections are going to have the same problems that this one has. So we have at -1 and +1, we have these asymptotes. So it's undefined here, they'll be undefined here, our slopes will be undefined. Right, and then here's what we have. We have negative infinitely small slopes, right? Or sorry, we have these almost 0 slopes that are getting steeper and steeper and steeper and steeper. So if I draw that visual of we have negative slopes, right, just smidge, we have negative infinitely small slopes getting infinitely large slopes. It actually graphs to the exact same thing when you're talking slopes. Right, so this is F prime. Okay, and then here I got a slope of 0. Let's call it a -1/2 maybe. So at -1/2, we have a slope of 0. We have negative slopes till we get here, and then we have positive slopes. We have negative y values. Those y values represent slope. And then we have positive slopes and getting infinitely steep. And then the last section is actually going to be like this section, kind of, but we have negative slopes, infinitely large negative slopes. And then they are gradually staying negative, but they are gradually approaching 0 slopes. So infinitely large negative slopes that are leveling off to very, very, very small negative slopes. Right? So a little tricky, but we'll do quite a few of these, trying to visualize the connection between the two, going forwards and backwards between the two of them. But this just gets us started a little bit.